Thank you so much, Dave. Thanks, everybody. I do appreciate you all spending the beginning of your Friday night to share information on climate change. This dramatic photo is the Amazon basin. And what I'd like to talk about is primarily climate change, but I also want to bring in biodiversity loss, pandemics, and the era of human inequality. And also to bring us up to speed on what's happening in Egypt and several reports that came out earlier this week and last week with regard to climate change. So here is the NASA surface temperature record. And we've now pushed Earth's average annual surface temperature up to someplace between 1.1 and 1.3 degrees Celsius. 2022 looks like it's going to come in as the 5th or 6th warmest year on record. And if you look at the cluster of last 8 years, you'll see that we have natural variability reflected there, El Nino and La Nina, and we have not dropped below 1 degree C. So it looks like we've permanently crossed 1 degree C at this point. And we are headed for 1.5 degrees Celsius by the end of this decade, according to some projections. This is our homegrown observation record of carbon dioxide at Mauna Loa. At the beginning of our observations, CO2 growth was less than 1 part per million per year, but now it has accelerated, and we see the concentration of CO2 growing at over 2 parts per million per year, and that's averaged over the last 10 years. So that's an important point. CO2 is not accumulating in a linear fashion, it is accelerating. Earlier this year, we crossed temporarily 420 parts per million. It looks like we're going to settle in at about 417 parts per million for the annual average for 2022. This is more than 50% greater than the pre-industrial level of 278 parts per million. More than half of all the industrial CO2 in our atmosphere has occurred since 1988, which was the year in July when NASA scientist Jim Hansen told Congress that it was his opinion that climate change was here and that we were observing the impacts. Now, 40% of the CO2 that we emit today will still be in the atmosphere in a century, and about 20% will be there in as long as 10,000 years. So this is the big problem with carbon dioxide, is it has this long residence time in the atmosphere. And so it causes essentially permanent heating from a human point of view. And once you warm the air, you increase the humidity, and that increases the most powerful greenhouse gas, which is water vapor, H2O. Now, water vapor has only a 10-day residence time on average. So there's no way to increase the amount of this #1 greenhouse gas, water vapor, unless you warm the air with some other gas like CO2 with a long residence time. This is called an amplifying feedback effect, and it's one of the mechanisms in the climate system that makes it so scary and has the potential to lead us into reactions, natural reactions in response to anthropogenic warming that become irreversible. In the last year, we've grown increasingly concerned with methane. Methane emissions have set an all-time record each year. For the last 3 years, methane's responsible now for as much as 1/3 of short-term global warming because it has a short residence time of about a decade or so. But it's far more powerful at trapping heat than carbon dioxide. Now, carbon is found in nature in 3 different isotopes. One isotope is carbon-14, and it disappears fairly quickly. Another isotope is carbon-12, which is a signal of plant growth. And that carbon-12 accumulating in the atmosphere is typically from fossil fuels. Fossil fuels are typically produced by fossil plants. But what we're seeing here for this methane accumulation is carbon-13. Carbon-13 is a signal of microbial decay, which happens with the expansion of wetlands. It happens with the thaw of permafrost. And expanding wetlands where wet areas are getting wetter because of climate change and growing permafrost thaw are natural reactions to the heating that we have caused and really are out of our control. This might be the first signal of aspects of the natural world reacting to our warming in a way that we can't directly influence. Another source of carbon-13 is the gastrointestinal indigestion that cows and other livestock create when we feed them corn, which they are not naturally adapted to. They are grass eaters for the most part. And so we get lots of methane production from cattle agriculture, which we can do something about. Now, we've just come out of yet another Northern Hemisphere summer with headlines of all sorts, reminding us that climate change leads to very dangerous impacts. We are living in hell. Pakistan and India suffer extreme spring heat waves over 122 degrees Fahrenheit. This is a warning. Spain reels from devastating blazes and heat waves. Record heat wave deepens Europe's energy crisis. The Loire River ran dry, and so they had to shut down 9 nuclear power plants in France because they didn't have any water for cooling. And we saw a record-setting heat wave in China, 70 days of record heat that, examining ancient Chinese diaries, scientists concluded had never been seen in the human experience in China. And this past fall, California set over 700 heat records. California and Western states set over 700 heat records. We also have floods in Pakistan, which are still causing severe damage. We had 2 million homeless, 1,700 fatalities. 9% of the nation was flooded. And now we're seeing the typical impacts after these disasters: food and water shortages, and the spread of disease. Dengue, typhus, and malaria is widespread in Pakistan. This is the record of billion-dollar losses in the United States. We haven't finished up 2022 yet, but we have drought, wildfire, flooding, winter storms, crop freezing, severe storms, tropical cyclones. There's a clear upward trend here in billion-dollar losses just in the US. So we all know about these impacts related to our greenhouse gas emissions, and we're familiar with the UN Framework Convention on Climate Change, which in 2015, the Paris Climate Agreement to stop global warming before reaching 2 degrees Celsius and to pursue efforts to end warming before 1.5 degrees Celsius. These are now benchmarks. And in 2018, a report by the Intergovernmental Panel on Climate Change came out examining what the world would actually look like under 1.5 degrees Celsius. And it was full of lots of dangerous information, human security at risk. And so 1.5 is now the de facto target for arresting global warming. Something we don't often see advertised, but which many scientists follow closely, I know I do, is this idea of climate tipping points where huge biophysical systems, biological and physical systems at a planetary scale appear to be reacting to the warming that's taking place. And this paper came out recently describing tipping points that might be passed if we breach this target of 1.5 degrees. Greenland ice sheet, West Antarctic ice sheet, low latitude coral reefs suffering from marine heat waves and surface heating of the ocean, permafrost abruptly thawing, Arctic summer sea ice abruptly melting, a dieback of the Amazon, and vertical circulation in the North Atlantic slowing down. It's already slowed 15 to 18%, but we're still not certain if that's natural variability or if it's related to the release of fresh water coming off of Greenland. So these are huge systems that have massive impacts far beyond what we may be aware of. So what is our progress on stopping warming at 1.5 degrees C? The bottom axis is the first half of this century. Vertical axis is our anthropogenic CO2 emissions. Here's the last decade of emissions, which peaked in 2019. The recession related to the COVID pandemic saw more than a 5% reduction in carbon dioxide. But with stimulus, economic stimulus released by the world's governments in 2021, we saw a return, an immediate return to using fossil fuels for producing global energy. And in fact, 2021 set a new record of carbon dioxide emissions. A report just came out yesterday from the Global Climate Project, the Global Carbon Project, projecting a 1% increase in CO2 for this year. So we continue to increase our emissions. Remember, we need to reduce emissions in order to stop warming, and this is the pathway to stopping warming at 1.5 degrees. We need to have net zero emissions by 2050. Now, under the UN Framework Convention on Climate Change, there is a mechanism for nationally determined contributions or commitments. This is nations pledging to cut their greenhouse gas emissions and also pledging to achieve net zero status by some target date. And if you add up these pledges, we're on track to arrest warming, to stop warming at about 2.5 degrees Celsius. This is near miraculous. 4 years ago, even, most climate scientists would have said this would be impossible. So this is truly an awakening on the part of the world's nations to the reality of the problem and stepping up with promises to solve the problem. But there's a difference between pledges and actual policies. And the actual policies take us to a much warmer world, averaging 2.8 degrees C, but potentially over 3 degrees Celsius, which is a real threshold for heating, dangerous humid heat. And the difference between these promises and the actual policies which are in place and the investments in fossil fuel infrastructure is called a gap. And every year, the UNFCCC, actually it's the United Nations Environmental Program, comes out with a report called the GAP Report. And this came out late last week. This year's GAP Report is called the Closing Window. Now, we learned from the Intergovernmental Panel on Climate Change reports, both this year and last year, that emissions need to be cut by 45% by the end of this decade, compared to 2010, in order to stop warming at 1.5. But the current commitments to cut emissions actually lead to an increase of emissions of over 10% by the end of this decade. So we're still headed in the wrong direction. So the GAP report. Since last year's Conference of Parties meeting in November in Glasgow, Scotland, nations have shaved only 1% off their projected greenhouse gas emissions for 2030. So we have not seen a recommitment to this problem since last year's meeting. Current climate policies put the world on track for, quote, economy destroying levels of global heating. And that's UN General Secretary Antonio Guterres. The GAP report tells us that there's currently no credible pathway to keep the rise in temperatures below the key threshold of 1.5. This is the first time we see this admission. Scientists have been saying this. I know I've been saying this for 8 to 10 years. Now we see it in print from the UNFCCC themselves. Incremental change is no longer an option. Avoiding dangerous levels of warming will require a wide-ranging, large-scale, rapid, and systemic transformation. Much faster changes to electricity supplies, industry, transportation, and buildings are needed, as well as protection of natural landscapes, changes to diet and farming, and cutting carbon from food supply chains. The financial system must be reformed to provide investments of $4 to $6 trillion a year in order to achieve this goal. Most of you are aware that the 27th Conference of Parties is taking place as we speak this week and next week in Sharm el-Sheikh, Egypt. We see lots of headlines coming out. Those of you who follow the climate news, show us the money. The developing world at COP27 seeks financing details. The World Bank tells rich countries, give us more cash for climate. Rich countries must stop stalling talks on climate loss and damage compensation. At COP27, support the poorest nations for climate loss and damage. Corporate climate pledges are rife with greenwashing, says a UN expert group. There's one big subject our leaders at COP27 won't touch, and that's livestock farming. George Monbiot. Climate emissions hit a record high in 2022. And it's a twisted joke that UN's flagship climate summit sees a sharp jump in fossil fuel industry delegates. There's something like 683 delegates at this meeting from the fossil fuel industry. 100 more delegates than last year. And the big quote from General Secretary, we are on a highway to climate hell with our foot on the accelerator. So what are the key issues at COP27? The first is progress. A global stocktake is what it's called. A global stocktake is where we meet on a 5-year cycle to assess the world's collective progress towards fulfilling the Paris Agreement. This needs to take place during COP27. The second big issue is nationally determined contributions to lock in national commitments to cut emissions well below 2 degrees C and ideally 1.5 degrees C. The third big issue is to strengthen the ability to adapt to climate change and to build resilience. There is a plan called the Global Goal on Adaptation, or GGA. It strives to increase ambition and to create a ratchet mechanism for adaptation, but it's got very vague guidelines right now. And one objective of COP27 is to add specific goals and commitments to increase them. We also have a demand to finance mitigation, which has been promised in the past but not followed through, to align finance with a pathway towards low greenhouse gas emissions. A significant point of frustration and anger among developing countries at last year's meeting was the failure to deliver on promises of regular climate finance. Developing countries hope to see the fulfillment of historic promises, such as the $100 billion annual climate finance, which developed countries were meant to deliver each year from 2020 to 2025, but which so far has not been met. The International Monetary Fund estimates that developing countries need $2.5 trillion of external financing per year to meet the Paris Agreement. There's also a demand for financial support for loss and damage. This would be support from developed nations who are responsible for climate hazards to assist the developing nations because of the destructive impacts of climate change that cannot be avoided at this point. Now, we also saw the International Energy Agency come out with their annual energy outlook last week. And this had some surprising information. The Russian invasion of Ukraine has sparked a global energy crisis. This has pushed up gas prices and spurred governments to speed up their renewable energy rollouts. New policies are propelling annual clean energy investment to over $2 trillion by 2030. This is a rise of more than 50%. However, clean investment could be even larger. If we redirected fossil fuel investments to clean energy, we could fully finance the wind and solar energy scale-up required to meet 1.5 degrees. By 2030, in the US, clean energy will grow 2.5 times over today's levels, and electric car sales are projected to be 7 times larger. There's a massive build-out in clean energy in China taking place, causing coal and oil consumption to peak before the end of this decade. And the share of fossil fuels in the global energy mix has been stubbornly high for decades at around 80%. And the IEA is projecting that this share for the first time falls below 75% by 2030 and to about 60% by 2050. Global CO2 emissions are projected to peak by 2025 and to fall by 13% by mid-century. Unfortunately, this is too little to avoid severe impacts from a changing climate and will probably lead to a rise of about 2.5 degrees Celsius, a similar number that we've seen in other analyses. Energy markets and policies have changed as a result of Russia's invasion of Ukraine, not just for the time being, but for decades to come. And the current energy crisis promises to be a historic turning point towards a cleaner and more secure energy future. But there's so much more to the story. 1 year ago, the Washington Post revealed an in-depth analysis and told us that on average, emissions are underreported by 23%. Earlier this year, we learned that methane emissions from energy production are underreported by 70%. We now know that permafrost is a net carbon source. In the summer, 1 billion metric tons of carbon are taken up each year by vegetation, but in the winter, we see 1.7 billion metric tons of carbon lost from Arctic permafrost regions. The Arctic is probably a net source of emissions at this point, and this effect is not accounted for in national pledges to the UNFCCC. Now let's look at CO2 emissions on average annually for the last decade. About 86% of our emissions come from burning fossil fuels, and another 14% comes from various types of land use. Not only deforestation, but also poor soil husbandry, where soil is exposed to the air, it oxidizes and turns into a source of CO2 instead of a sink. Of this released CO2, about 46% goes into the air and traps heat that would otherwise escape to space. About 31% is absorbed by photosynthesis by plants on land. And about 23% is dissolved into the ocean, leading to ocean acidification. What many people don't realize is that this photosynthetic storage is at a limit. There are many papers coming out now that remind us plant photosynthesis removes CO2 from the air, but plants also respire CO2. That is, they release CO2 and water vapor to the air. And photosynthesis has a heat limit Past this thermal threshold, photosynthesis sharply declines and respiration continues to increase. At this heat limit, carbon uptake by land plants is degraded, and with continued emissions, models tell us that carbon uptake may be degraded by nearly half as early as 2040. This effect is also not accounted for in the UNFCCC. The latest paper on this issue was published in Proceedings of the National Academy of Sciences. It concludes that warming will lead to reduction of carbon assimilation capacity and eventually heat damage of plants, as multiple studies suggest that a variety of ecosystems are already operating at or near their thermal thresholds. We need only look at the Amazon, which suffers not only from heat, but also anthropogenic damage. The Amazon contains more than half of all tropical rainforest. Logging, mining, hunting, deforestation, damming, drought, and tree mortality are all taking place there, such that the Amazon lost 1/3 of above ground biomass over the last decade. From 2010 through 2019, the Amazon basin released over 18 billion tons of CO2 equivalent, but only sequestered or drew down a little more than 15 billion tons. A number of papers are now concluding that it's likely that the Amazon is a net source of greenhouse gas emissions. This is a map of anthropogenic impacts. More than half of Amazonia shows some type of human impact, 52%. Everything from yellow to deep red. And using satellite data, we can look at the entire tropical rainforest for the planet. Between 2001 and 2005, tropical rainforest belt released about 1 billion tons of carbon per year. But more recently, it has released about twice that. So we're seeing a doubling of carbon release from tropical rainforest. 82% of this carbon loss is the result of human agriculture in the tropical rainforest. And the paper concludes strategies to reduce forest loss have not been successful. And we all know the world is growing hotter, especially on land in the summer. If global temperatures rise 2 to 2.5 degrees C above pre-industrial levels, densely populated urban centers in Asia, the Middle East, and North Africa will suffer recurring, life-threatening heat that will bring temperatures beyond the human survivability threshold. This would affect as much as 600 million people. Another model paper from Proceedings of National Academy of Sciences tells us that today, less than 1% of Earth's land surface is too hot for human existence. These black areas in the central Sahara or along the shoreline of the Red Sea, these areas are too hot for human existence. But if we reach 3 degrees Celsius, which current emissions pathways will take us to in as little as 50 years, we're looking at nearly 1/5 of Earth's land surface having the equivalent conditions of today's black areas there in the central Sahara. More than half of Australia, most of Southeast Asia, India, the Middle East, North Africa, more than half of South America, and large parts of Central America. In fact, from today, for every additional 1 degree Celsius of warming, we're projecting 1 billion individuals displaced from their communities because of food and water scarcity, rising sea level, and other issues related to this warming. Climate change and expanding human needs have led to food and water impacts across the planet. We are currently pulling 17% more water out of our continental aquifers in North America than nature can replace every year. China is doing the same. India, the Middle East and North Africa. We are drawing down the major aquifer systems of the world. And the water demand by mid-century is projected to grow by more than half. We're already looking at 17 nations under extremely high water stress, meaning that they use almost all the water they have every year. And the southeast coast of India, we have the city of Chennai, 11 million people, a little larger than New York City. In 2018, it ran out of water. 4 huge reservoirs went dry because of the failure of the spring monsoon that year. We also see a decline in micronutrients related to the 4 fundamental cereals that provide humans with their nutrition: soy, maize, wheat, and rice. We see up to 13% reductions in protein, which are being replaced by carbohydrates, zinc, vitamin B complex, and iron, simply due to rising CO2 in the air, where plant metabolism invests more of its energy in the stalk and the leaf and less into the food portion of the plant. We can look at wheat as an example, which today provides about 1/5 of human protein on the planet. The yield is threatened by not just higher CO2, but also extreme weather events. And by 2050, the demand for wheat is projected to increase by 60%, but the actual yield projected to decline by 15%. And of course, this leads to food shortages, price spikes, food riots. And by 2050, an additional 300 million people are projected to be malnourished from this micronutrient effect of rising CO2, and an additional 1.4 billion women and children likely to have iron deficiency. There are huge global security issues associated with warming and all of its impacts. And the Council on Strategic Risks has said that even at scenarios of low warming, each region of the world will face severe risks to national and global security in the next 3 decades. Higher levels of warming will pose catastrophic and likely irreversible global security risks over the course of this century. At the same time, the natural world is being sacrificed to human consumption. Since 1970, the per-person consumption on this planet has increased by nearly 60%, and global economic activity has grown 4 times. Much of this growth has come at the expense of the natural world, which is now increasingly managed to keep up with the demand for food, energy, timber, paper, minerals, and more. This paper in Science says that this is an unparalleled appropriation of nature that is causing the fabric of life on which humanity depends to fray and unravel. Since 1970, food crop production has increased 300%, and half of all agricultural expansion has come at the expense of forests. More than half of deforestation is to raise cattle and the grain to feed them. 50% of habitable land, 2/3 of all freshwater use is for food production. Over 80% of farmland is used for livestock, but it produces just 18% of our calories. Cattle and the grain they eat use 1/3 of available land surface on this planet, 16% of all available fresh water. 1/3 of worldwide grain production goes to feed cows. And producing beef generates 100 times more greenhouse gas than plant-based food. Estimates are that 86% of all land mammals are now livestock or humans by biomass. Of all birds, 70% are poultry. And human overconsumption and population growth and intensive farming has destroyed as much as 69% of vertebrate wildlife since 1970. Biodiversity loss is linked to the spread of disease. We've now entered the era of pandemics. There have been 335 new infectious diseases since 1970. 75% of these are zoonotic, which means they jump species from animals to humans. Ebola, HIV, malaria, West Nile, anthrax, encephalitis, Zika, SARS, MERS, COVID-19, and many, many others. These are called spillover events, where microbes that are carried by animals cross into the human community. And there are 4 venues for these spillover events. The first is habitat loss. Roughly 1/3 of new zoonotic diseases are directly attributed to disturbance of natural biologic systems. Deforestation and habitat loss releases these microbes into the human community. About 50% of the world's original forests have now been eliminated. And globally, we cause the net loss of about 10 billion trees per year. This fact continues to stun me. Less than 3% of Earth's land surface remains faunally intact. Predator-prey relationships, seasonal patterns, mating, food chains, natural ecosystem energy cycles. Less than 3% of Earth's natural systems are still intact. We also have extreme weather events. And during extreme weather, human immune systems tend to be weakened, and disease is a major problem. Our third spillover venue is vector expansion. The tropics are expanding. Mice, mosquitoes, ticks, deer, and other carriers are moving into human communities that had not experienced them before. And we've also seen the large-scale loss of predator species or apex species, so that small mammals are exploding in population. Small mammals and mosquitoes are very successful at living cryptically. They can live right in the midst of our urban setting in a very hidden fashion and distribute disease. And our fourth venue for disease is concentrated animal feeding operations, which are a breeding ground for virulent pathogens. In factory farming, there's no natural evolutionary pressure to limit the virulence of pathogens. In nature, a virus cannot afford to continuously kill its host, or it will itself go extinct. But in factory farming, every dead animal is pulled out and replaced with a living animal. And so genetic mutation leads to increased virulence, and there is no evolutionary stopgap. There's no filter or limitation to this. And so we have things like certain strains of avian flu, which have a 68% fatality rate. Now, thank goodness, these truly catastrophic pathogens have not yet evolved strains that have spilled over into human communities yet. But many epidemiologists fear that it's only a matter of time. We keep these animals alive by pumping them with antibiotics. And nearly 2/3 of drugs that humans use in the US are sold instead for food animal use. And this, of course, drives bacterial resistance, which we all see taking place in our hospitals. Disease, environmental damage, climate change, and human inequality form an amplifying feedback. Disadvantaged groups suffer disproportionately, resulting in greater inequality. We also have most of the nations in this red belt and the tropics having been heavily colonized over the last 500 years. And broken political systems, broken cultural systems through colonization amplify the negative impacts that these other global scale crises are creating. The ratio between the income of the richest and poorest 10% is 25% wider than it would be in a world without global warming. The richest 10% of the global population owns over 3/4 of all global wealth. The poorest half of humanity owns just 2% of global wealth. Here's our history of CO2 emissions, and this needs to be the future. We gain an extra 15 years if 2 degrees Celsius is our target. Emissions must peak by 2025. We need to cut between 40 and 50% by 2030. And we must remove CO2 from the air beyond this century with infrastructure that's nowhere in evidence today. This decade, 2020 to 2030, is a pivotal decade for all humanity. And so I'll conclude with optimism overall, yet worrying trends persist. Likely scenarios of future warming are now 25 to 35% lower than they were just 5 years ago. Early signs of a clean energy transition are emerging, and climate policies are being implemented by governments, and they're working to some degree. Climate change just needs to happen faster. Global carbon emissions growth has slowed, and at least 18 countries have managed to cut their emissions consistently for more than a decade. Renewable energy is rapidly getting cheaper. Over the last decade, the cost for solar energy fell by 85%, and wind energy fell by 55%. Investment is pouring into renewable energy at a record rate, with $226 billion invested in the first half of this year. Global energy demand growth will now almost entirely be met by renewables. Economic growth no longer requires rising emissions. America has reduced emissions from over 6 billion tons of CO2 to just over 5 billion tons. And US consumption emissions, which include carbon embedded in imports, have fallen by 15%. High gas prices have made cutting emissions cheaper. Energy efficiency improvements have delivered huge gains. New countries are passing climate laws, and 91% of the world's GDP is covered by countries with a net zero target. Unfortunately, there's still no credible pathway to stop warming at 1.5, but we still have a chance of stopping warming at 2 degrees Celsius. And I'll end with this quote from Lord of the Rings: "We don't choose the times we live in. The only choice we have is how to respond." And I'm happy to take any questions you might have. Thank you very much.
Hello, Chip.